What?
For like her research project for Ava Pazos.
I hate that kid. I'm just kidding. I'm just kidding.
Can I put it here? I'm gonna put it.
Ava Pazos.
Go fill it out.
Or I hate her.
I will.
Use AI? No. Use her research?
I will. Go fill it out.
What the heck?
How much you need to play me one-on-one for basketball?
Okay.
Bruh. Alright, get your homework out with homework hard.
Yeah, I will give one for free. We're all You know, you guys are going to the coverage that you need to read for that. Can you tutor me? And actually pull off the face down.
Yeah, it's better.
Mr. Gay, I had to.
I got math competition.
Way more expensive.
Damn, do competition for the bombs. Yeah, I saw how that ended in my single time. Okay, bro, who was it? Alan Gonzalez?
And they both beverage it.
You like that?
I saw how much it
I got in there and
Never seen anybody
No.
yeah. Not that much.
You'll have to make the competition test that you guys are big. You're not doing it all.
Wait, but you're not in the
Go all the way. I'm thinking you're that part is shit, bro. You're gonna be sitting there looking at it. You're gonna be sitting there looking at it like a laptop. You chose movies. You two got kids with me the other one?
Yeah, but you said screw it. We and our she was like rooting to play.
Bagel cheat sheet. After Oliver.
One man for himself, and he was looking out for himself, and now he's looking out for himself. once
Jones.
you're facing
I love this show.
understand like you understand what he was doing, just like
Like she makes you want to do her
older
homework.
generations are using people that are being inspired the younger generation to pick up their cloth.
I'll give her this. He can't do anything to you. That was illegal way of leaving. If he called people, they're just like bitter for you. They're not.
And that although the immigration factor is to it, eventually they are able to get mitigated.
Dude, it's bad. Like, I don't know what it's like now, but
All right, so shh.
It's just the rule. You mean it's just the small world.
let's start. So, you're proud of next year.
I've read that book before.
All right, homework questions.
Can you go over 13 and 14?
What does starting says?
Integral of x squared minus 7 over 7.
Why does everybody ask that question? That's like one of the easier questions, believe it or not.
Hard time with division.
Yeah, no. You're not the only one. I'm trying to say it's like that's an easy question. I don't know why everybody asks that, but this is actually just
Split it up.
yeah, you're supposed to split it up.
Okay, that's what I
Shh.
did, but I wanted to make
A plus B over C is equal to A over C plus B over C. In fourth grade, you learn this way. Shh. In fourth grade, you learn this way, and in high school, you do it this way. So, because in fourth grade, you learn like 1 over 5 plus 3 over 5 is equal to 4 over 5, right? But now we learn backwards. Okay, so what was the question? X squared
minus 7 over 7.
over 7x split.
You and your
Okay, so that is gonna be like this, and then that's gonna be 1 over 7x minus 1 over x dx. So this one is gonna be x squared over 2, so it'll be 14. Is that okay? And the minus natural log of x plus c.
Yo, can you do number 3 on the second page? It was like 1 to e of 1 plus ln of x squared over x.
Yeah, that's easy. Okay, so that's on the test, by the way. You asked a good question. Which one is that? Hold on a second. Let me
It
go.
was 1 to e
1 to e,
1 plus ln of x squared.
1 plus ln of x squared.
Yeah, whole thing squared over x dx.
Okay, this is a good question. U equal to 1 plus ln of x. Why? Because du is within the questions. Do you see that? Do you see that?
Yeah.
So that's going to be u squared x, and the dx is going to be x du. So x cancel out, so it'll be u squared du. Now I'm going to plug in the upper bound and lower bound. What is it? 2, right? Ln of e is 1. 1 plus 1 is 2, right? 1, right? 1 to 2. Is that okay? Is that okay? And then it's u3 over 3 between 2 to 1. And it's 8 over 3 minus 1 over 3 is equal to 7 over 3. Is that okay or no? Yes? Everybody agree with this one though? Did I make any arithmetic mistake? I plug in 2 to the upper bound.
You did 25.
Wait, somebody asked somebody first. Samuel, you asked something first, right? Did anybody ask a question before 24? 24 and 25?
Yeah.
Okay, so 24 first and 25. What 24 says?
It's dx over x times ln x squared to the 5
ln x squared to the 3?
Yeah.
Okay, did you do math first? I'm
Yeah.
saying math is like 2 ln of x to the third. I feel like that's easier. And then u equal to 2 ln of x, du equal to 2 over x. And then du x equal to over 2 equal to dx. So that's equal to ln x on the bottom. Seriously? Okay, u to the 3, x du over 2, cross it out, integration of 1/2 of du over u to the third. Now be careful, this is not natural log if it's something u to the third. Only u to the 1 on the bottom is natural log. So this is just simple power rule. Move it to the top. U to the -2 over -2 times 1/2 plus c. So it'll be 1 over -4 times 1 over ln of x square, I think, plus c. Is Caden coming? I'm gonna keep a count. Caden's versus Alden. Right now, Alden didn't show up today, and Caden didn't show up.
Yeah. Just do a tally on the board.
Yeah, I'm start doing tally. I say, which one should I fail? Aiden or Alden?
Yeah. Give him a 0 in the homework grade, that'll scare him.
Next question.
25.
25. What's 25?
Integral of 1 over square root of x times 1 minus 3 times square root of x.
I like this one. I like this one.
I don't.
Anybody got this one right?
No. What's there?
This one will be on a test. I'll put it on a test.
Oh,
It's not as bad. You're gonna see the pattern. U is always 1 minus 3 root x. And you have to have a faith. Keep on going. Don't stop. du equal to, this one is 1 minus 3x to the 1/2, right? So it'd be minus 3 times 1/2 x to the negative 1/2. Is that okay? du equal to -3 over 2. This is the square root x, right?
Yeah.
Can I move to the other side? Do you see it? U, 1 over square root x. This one is going to be dx will be 2 square root x -3. This will cancel out nicely. Right? So it'll be 2 over -3 integration of 1 over u du. And that's going to be 2 over -3 natural log of 1 minus 3 root x. Yeah. Is that okay? Absolute value, actually. How many of you guys got this one? Emily, good job. Okay. Hannah, Oliver, good. Nice, nice. Samuel, nice. And this is a good one. Any more questions?
26.
Same thing. You do it.
What about 58? Yeah, the last question.
Did I assign 58? I don't think I assigned 58.
Wow. And I did 56, 57.
Yes.
Can you do 27 or 28?
27.
I like both. Hey, nah.
Do 27.
Right now.
Leon, you're better than that. You can do those questions easily.
Guilt tripping.
Call her up, not-
You definitely could have done this.
I definitely could have done this, but like it was like I don't know how 20 plus and like I couldn't do all of it. I have other work to do, Mr.
I think we do.
Didn't even do it over.
I can like mental.
Mental it.
Like just calm down on the homework, like
Larissa.
just a little bit.
You need to start making Sepper's test grades.
Why?
We got 2 student of the month.
Oh, Sepper is about gonna fail both
What?
classes.
We have 2
I'm
student
not
of the
gonna
month.
fail both of those.
Who?
We have 2 student of the month in here. Let's just say that.
Oh, yeah.
She made it.
It was so crap. I'm really upset about that.
All right, so anybody got this one? Emily got it.
I think I get it.
Then you got it. Okay, nice. Fabian got it. Okay, good.
Wait, question.
Samuel got it.
Whenever we do the
Samuel got it, and you didn't.
I
No
didn't even
way.
try. Yeah, I didn't have time.
Yeah.
Whenever we do the we always have to put the values. Oh,
Yes, technically yes. I mean, you don't have to because most of the time, with definite integral it matters. Because indefinite integral doesn't really care, but definite integral.
so like
Um,
if we didn't write it, you wouldn't think my fault.
You should write it. So those of you guys did it. I you know, sometimes like you gotta put in like this question is kind of challenging. It's not easy, no. But yeah, you should.
Now I want to solve it.
You should solve at home.
I didn't have time, Mr. A.
You don't have time for math.
Wait, are you not gonna do it?
And next year, tell me you're not going to the competition.
I'm gonna hold back on my attack.
Do another Jacob to lead.
Huh?
Do another Jacob to lead. Push him down.
Okay, so here it's gonna be u to the third, right? U equal to x minus 1, right? And that is u to the third. Now the problem is you got an x and x minus 2. Now when it happened like that, when this and this is same degree like this, usually involve with the backsub. Okay, so u plus 1 equal to x, right? U plus 1. And then, well, we can replace that as u plus 1 minus 2. So it'll be u minus 1. It's actually a really cool questions. If you did it, you should be proud of yourself. That's an awesome question.
Wait, let me see the question again real quick.
So this one is going to be u minus 1 over u split. Right? And then this is a u squared over 2 minus natural log of u plus c. And then it's going to be x plus 1. Or x minus 1, sorry. X minus 1 squared over 2 minus natural log of x minus 1 plus c. Uh-huh.
What happened to the cube?
Oh, I sorry. I forgot a q somewhere. Okay, so that's fine. We can erase this part. Sorry, my fault. This one is gonna be 1 over u minus u to the negative 3 du. Is that okay? That's gonna be ln of u minus integration of u to the negative 3. You get u to the negative 2 over negative 2. So be plus 1 over x minus 1. There was 2 here. Plus c. Is that okay? Square.
Square.
Is it our Bible?
Yeah.
No, it's 2 minus becomes positive. This is minus.
It's already
He split it up. He did u squared over u third
You got that.
minus
Plus
1
1
over
minus
What?
the u plus 1 minus 2. So minus 2.
Because I replace this x as u plus 1, right?
Oh, u plus 1. Okay.
Okay, so this is a good question. This is a fantastic question. Great question. Next question.
Yeah. So do you multiply the x by x minus 2? Or do you plug in u plus 1?
I plug in u plus 1 to replace the x because x should be u plus 1, right? So this is u plus 1, right? And there's a u plus 1 times u plus 1 minus 2, so it'll be u plus 1 minus 2, u minus 1. So this is called difference of a square, so this becomes u squared minus 1. If you expand it, it's going to be difference of a square. Very good question, by the way.
This is actually like
Yeah. All right, next question. So we're gonna one more question to go. Any more questions for homework?
55. What?
50 word long division.
That's the thing. That's what I need help with. I know.
What'd you get for 27?
Wait, what?
27.
X plus 1. So this is x. This is x squared plus x. This is minus. This is 0. This is negative x minus 2. Is that okay? Minus 1 minus x minus 1. And this one's going to be negative 1. So that's the integration of x minus 1 minus 1 over x plus 1. Is that okay?
Yeah, why are you
That's not synthetic division. That's
and why aren't we using synthetic?
You can. I mean, I like long division because why not? It doesn't take me long to do. All right, so I'm gonna integrate this x, and that's gonna be x squared over 2. I'm gonna integrate that. That's gonna be x. That's minus natural log of x plus 1. Now you're gonna put down, like, I will say, oh, what is it? From where to where? 0 to 2? 2. So it'll be 2 squares 2 minus 2 minus natural log of 3, I think. Minus 0, 0, 0. So is 0. So is going to negative natural log of 3.
I solved it.
You should solve it at home.
I solved it at home.
What happened with this?
Here. And here.
How much more do you guys have?
Look, that's what I'm saying. If we had less.
Little.
Oh, shit.
Too little.
I'm gonna say something, but I'll say it privately.
Yeah. Gabby just texted me. Tell Mr. Ye I made top 10 because he thinks I'm stupid.
I never think she's stupid. What the hell is she saying?
Hell are you saying? He said, I never believed in you. I never say you stupid.
That you put it in text, that's worse.
She got top 10 GPA. Jacob. She got top 10.
She is a top.
All right. All right, we're going to talk about today's stuff. So this is all the index card material. So we are going through all the trig integrals, all. So it's good to make an index card. So Integration of sorry. This is the one that we already know. What's the integration of sine of x dx? Negative cosine of x plus c. Okay? Integration. Trust me, if I think you're stupid, I'll call you stupid. I'm not gonna hide, but I'm not gonna hold back. No. Cosine of x dx is equal to what? Sine of x plus c. We already know this. What else we know though? What's the integration of any trig function that we know? Secant, okay, actually that's good. Secant x tan of x is equal to what? Secant x plus c, good. Okay, what's the integration of cosecant of x, cotan of x dx is equal to what?
Integral of secant squared dx is tan plus c.
Very nice, very nice.
Yeah.
Tan of x plus c. Integration of cosecant square of x dx is equal to negative cotangent of x plus c. Okay, so this is the one that that we already know. I'm gonna talk about. There's another two that we sort of know. We sort of know. So this one is we sort of know. So integration of tan square of x. That one we sort of know. That one's like inferring. So does anybody know what's integration tan square of x?
2 tan x secant squared x.
No, you are thinking about derivative. Separate. What's the integration of tangent square of x?
Wait.
Oh.
Fail.
Is it like formula or
Oh.
theory?
BC for what?
BC more like.
Hannah?
I don't know what tan is.
Tan squared plus x.
What?
Tan squared plus x.
That's good.
Oh yeah.
That's equal to secant square of x minus 1 dx.
Sure.
Because that's the Pythagorean identity.
Ah.
And that's 10 of x minus x plus c. So this is inferring. You have to infer with your own knowledge. Now this one is not on the AP exam, so you don't need to worry about it. But just so you know that this is inferring what you're gonna get. So what's the integration of cotan of x? Right. So we can change that to cosecant square of x minus 1, right? And this will be negative cotan of x minus x plus c. And this is the one that's inferring that you get from before. Now, which trig that we don't know? Integration of what? Tan of x. Okay, so also integration of cotan of x, right? Also integration of secant of x, right? Integration of cosecant of x. Okay, what's this part? Now, how do I find the integration of tangent of x? Very good. You're also inferring. No, there's no quotient rule integral. But why do we teach tangent until now, not first time we introduce? What? Somebody said something. You had to use ln. Okay, so u equal to cosine of x, du is equal to negative sine of x dx, and du over negative sine of x equal to dx. So that's equal to integration of cosine of x is u, right? And this is sine of x. This du over negative sine of x, cross it out, is equal to negative du over u. That's equal to natural log of cosine of x plus c. Does that make sense? Yeah, there's a negative there. So, using same logic, what do you think integration cotan is? Use the same logic.
Use the same logic, it's probably the same.
So, what do you think is it, Jacob? If you're using the same step, what would it be?
Say that we are going to do integral of cosine of x over sine of x. And then we're going to set u equal to sine of x. And we're going to find that du is equal to cosine of x dx. So du over cosine of x equals dx. So then I'm going to plug that in for dx. And it's going to cancel out with the cosine. And I'm going to be left with du over u, which is going to equal ln of sine x plus c.
Whatever you're having, I need to have some. That's pretty impressive. I mean, you can actually like see all those things inside your head. That's really good. Huh? So you gotta share those pills.
Is there a negative?
Maybe.
All right. All right. So what's the integration of secant of x?
Why is there no negative?
Ah, you figure out.
I have it, but there's a negative because when we cancel the cosine, there's a negative.
What's the derivative of sine of x?
Negative cosine x. Oh, derivative. Sorry, I was looking at the integral. But what does the derivative have to do here?
The derivative is what made it negative in the first place. The derivative is
Okay. Now this one, it's a you're gonna appreciate math with this, and you're gonna appreciate like people who come up with this. I always say like there was not many people in my lifetime when I was teaching things who can come up invent math, like who can invent things. There was maybe 2 students total. One of them named Isa. He's very smart. He have a D in algebra 2 and went out get a 5 on A, B, and 5 and B, C with the highest like multiple choice question. Like he would get 44 correct out of 45. And he would not take notes in my class. He would not do homework in my class. He will play Rubik Cube the whole time. So he's one of the different species. There was another one. His name's Ethan. About 4 years ago in Olympia. No, not Sorrow.
Here.
And then, so Ethan will be playing League of Legends in my classroom, mobile version. And I would throw his phone out the window, and he got mad at me all the time, and I got mad at him all the time. So I will cuss him out in the classroom. But Ethan was so smart that he come up with this washer method. Like Sepper can tell you, like it is a hard section. He actually just see things. It's like, oh yeah, I give him a shape, and he's like, yeah, I got the volume of the shapes, and he come up his own disk and washer method and shell method. Very impressive person. So actually, he didn't get a good grade on AP exam. He actually got a 4 on AP exam. And yeah, so he was a very very bright. He's the second person I think like super out of chart. Now I want to show you the integration of secant of x, and I want to show you the mathematician. They are actually like a lot of people think math is boring. There's no there is no creativity. I really want to share with you that this requires creativities. This requires creativities. So integration of secant of x, I cannot convert to 1 over cosine of x. That doesn't change anything. That doesn't change anything because you cannot do u equal to cosine of x, du is equal to negative sine of x. That doesn't, you cannot take an integral just based on changing the cosine of x. So what the mathematician come up with, they come up a way to do this. They say, wait, integration of secant of x. And what they did is they are so creative. They are so creative. If you think like Oppenheimer, you think about like Einstein, they are one of the most creative person in the world. They can see things without writing down, like Stephen Hawking, Einstein, Oppenheimer. They all can do the same thing. Is they don't need to write down. They can kind of see things happening. So what the mathematician come up with is they say, hey, let's multiply by this. So you're like, wait, how did mathematicians come out? They couldn't multiply any trig function, but they come up with this particular one. Secant of x plus 10 of x over secant of x plus 10 of x. Do you guys see why?
You can't stand out.
Okay, so what Hannah says, let's distribute this. Yeah, that's gonna be, hopefully you see stuff. And why is that? Why does that help me? It's just to make it look more ugly than before, but why does it help me? You take a derivative of those two things. Oh yeah, you can read it the other way too. So you say u equal to secant. So u equal to secant of x plus 10 of x. Du is equal to secant of x 10 of x plus secant square of x dx. Do you see that this is the whole thing on the top? And this is u, and this is u prime, right? So this is integration of du over u. And that's just going to be, oh yeah, natural log of secant of x plus 10 of x plus c. And that's it, done. Now, I don't know how this mathematician come up with this. It's just like very, very impressive. Like they can see things like 1,000 miles ahead. Like they can see, like Einstein can see like, you know, speed of light and he can picture things before it's proven. And that's why I said it's only one of the, you know, every time about 1 out of every 10,000 kids that can come up with a creative way to look at something, and they can invent math and they become future, you know, like mathematicians if they decide to go to math. But one, probably they are not going to math. They're probably going something else because math doesn't make a lot of money. So, but it's definitely creative. You have to appreciate this creativity. That this is actually pretty impressive. So what would be the integration of cosecant of x? Using same logic, what do you think my answer is going to be? So think about pattern. negative ln. Yep. Jacob is actually pretty good at pattern organization, which is you will actually enjoy. You will actually enjoy like maybe BC stuff, but I don't know if you want to go to BC.
No, I think you got it wrong.
Maybe I'm wrong. All right, so is that okay? So now we learned all the trig integrals. You guys gonna have to apply those trig integral and on things, but I'm not stop teaching it. I'm gonna start teaching the next section. In your homework, you're gonna have to deal with average value. Hopefully, you know how to find average value. What's the equation for average value? Okay, good. So yeah, you're gonna have some question like that. You're gonna have some the question that's very important. But now we're gonna teach one more thing before the class end. What time is class end? 10:06. Okay, that's good enough. Okay, so I'm gonna teach something that's very difficult in the next 6 minutes. Okay. You ready? Shh. You better pay 100% focus. Okay. We're gonna teach you how to take a derivative of the e to the x. Okay. Derivative e to the x will take you like 10 second. E to the x. Derivative e to the x is e to the x.
Why? I can't believe I got a question wrong.
Derivative of e to u. Wait, it's on Quizable? What are you talking about? What you got?
On your test, there was one where to get one of the answers, you had to take the derivative of e, and it was the derivative of e, but I thought it was e of x.
Oh no, e. Oh yeah, e. So what happened is there's a chain rule here. So there is a first layer and there's a second layer. So therefore, if you derivative e to any other thing than x, then it's gonna be eu. You're gonna assume that's u, and also times the du dx. So for example, you can take a derivative of the e to the 3x. What's derivative of e to the 3x? You're gonna write out e to the 3x. What else? Times 3. There we go. 3e to the 3x. Now I'm going to show you a algebra proof of derivative e to the x. And the algebra proof is actually not that bad, but the geometric proof is kind of hard to see. But if you guys are interested, you can watch a video of 3 Brew, 1 Brown. They'll actually show you the geometric proof of e to the x. And they are phenomenal videos. They are one of the best math video out there. Y equal to e to the x. This is what we're going to take a derivative of. But before I take a derivative, I will take a natural log of both sides. So it'd be natural log of y equal to natural log of e to the x. Is that okay? Well, ln of e is what? 1. So it'll be ln of y equal to 1. Is that okay? Now remember, I want to take a derivative of that. Derivative of, huh?
Does the x just go away? It cancels out.
You're right. This is x. So derivative of ln of y is going to be y prime over y, right? And derivative of x is 1. Guess what? Y prime equal to y. The derivative of y is equal to y. Okay, so this is how the creativity in math, that's very important. Okay, we are gonna teach you how to take a derivative of this one. So how do I take a derivative of e to the 3x minus e to the x minus 1 over e to the x? You split them. Good job. Always thinking about algebra before you do anything. So if I take a derivative of this, it's going to be e to the 2x minus 1 minus e to the negative x. If I take a derivative, don't forget the chain rule. If you have first layer and a second layer, right? So it'll be e to the 2x times 2. Is that okay? Take a derivative of this one. Again, there's a chain rule. So it'll be minus negative e to the negative x. Why? Because derivative of negative x is negative 1, so that's us get negative in front of it. So that will cancel out. That's fairly easy, right? Okay, let's take a derivative of this one, and also you need to simplify. The bottom is not one term, bottom is two term here. You cannot split this one. But you can do a, what kind of rule are we thinking about? No. What kind of rule are we thinking about? Quotient rule. Yeah, because this is a quotient, right? Well, just do quotient rule. I always think about basic things. Don't think about something too complex. Huh? Yeah, don't get confused with integral and derivative. We keep on intertwining to mix the derivative and integral right now, just because I want you to get used to, like, what are you doing? Okay, let's take a derivative of this. Low d high times 3e to the 3x. Is that okay? Minus high d low, which is what? E to the x. All over e to the x plus 1. Now, I will always factor out a common factor because this is a common factor. Right? Did you see that? I can factor out. So e to the 3x, and that's going to be 3 times e to the x plus 1 minus e to the x over e to the x plus 1 to the square. Then that's going to be e to the 3x. I'll distribute the 3. So it'll be 3e to the x plus 3 minus e to the x over e to the x plus 1. This two are like term. So that's going to be e to the 3x over 2e to the x plus 3 over e to the x plus 1 squared. And this is the most simplified term. Yeah, it's not difficult. F of x equal to x e to the x. This is very easy.
No, that's just like product.
That's just a product rule. Instead of equal to 0. So product rule is this times this, right? So it'll be 1 times e to the x minus x e to the x, right? Can I factor out e to the x? Is it plus? Sorry. Now can I do a number line? Does e to the x ever become negative? Or they become 0? 1 plus x, so this is a negative 1, right? So positive, positive, negative, positive, positive, negative, min.
was David's turn. Should be like a medium.
If suddenly we will have state derivative from this equation, will it turn out to this one?
You can try it.
I see. And I have why we always use natural logarithm? Why we don't use just logarithm?
That's a good question. Usually logarithm can be replaced with natural log because they operate the same way. But I don't think you can replace with log because it's base of 10. Let me think about it. I don't know how to answer that question because I'd rather make sure I answer the question correctly because that's a good question.
Okay. In the first, like, on Monday, you said about, oh, we're going to have logarithm, we have natural logarithm.
Yeah, because usually in calculus, after that, we always use natural log. We never go back to log again.
She's lazy.
I think you know what I'm gonna say.
I don't know.
We drew stuff and something else. Don't erase. We drew stuff this time.
Look at the format, bro. Y'all leave the door immediately. I said bye, bro.
Nothing?
Just redraw. Yeah.
I think you know. What?
Is it the same thing
Yeah, I'm
as
over
like last time? Or is it something new?
Alcohol, bro.
I don't know.
No, get it.
Okay. Bye, Lian.
Yeah, I'm going to
Yeah, I gotta close it down.
Bye.
Babe, you're not gonna grade us today either.
We're gonna go to second series more. We got a lot of things to do. A lot of things to do.
I don't know. I feel like besides the so I did the Euler method, honestly. Isn't that crazy?
You are idiot.
I did the easiest one though. No, it's not.
How's life?
Life is good. Life is very stressful. But I'm surviving. Busy.
Hayden, how's your life?
Nice to eat and just like
Cause he's my cousin, bro. I'm gonna marry him soon. They bully me, then.
don't erase.
And they say I look like Craig.
Conjugal is kidding.
I gotta finish it straight into like a signature. Connor really wants to.
Just like okay. Now I want your feet is up there.
I had a break, sir.
Supper.
Low-key, I calmed it down, bro. I don't think I'm gonna get it anyway, but like. My son is on the internet, shut down, bro.
I think you know.
No word.
We'll see.
Alright,
Let me take a fun little surprise, see what I get. Here. My favorite. We're all in space.
Everybody out, bro. Whoa! That was me.
Lost, guys.
I did it.
Very few people are
No, I might get a 70%. He's gonna think it's you. Watch out for Peter, but Peter on God.
Where's my pencil?
Or are you gonna move up there? You know what?
All right, so thank you. What? Somebody said something.
You're too talking.
Your head's too big.
It's my hair, not my hands. I have a lot of
Your head's too big.
all the calculus knowledge. Go.
Hopefully at 15.
Yeah, me too. I'm gonna turn it. I love the progress. That's for you have a like
All right, so we got where's Emily? Why?
because next year we have an English test and the following year we have a physics test. It's the hardest year. It's the hardest we give mystery A the effort. Mystery
No. I don't know why you guys putting my class over my physics over me, but I don't know. I'm kind of insulted. All right, so so yesterday we talked about monotonic. Two ways to prove monotonic. What's the first way? Derivative. What's the second way? You compare your next term with the private term. Huh? Eli method, just look at it, right? So now we finished that there is a bounded behavior. We finished that the bounding sequence. So we finished 9.1. So those total like 8 sections. So we finished the first section. The second section is actually slowed down a little bit. It's actually not as hard, but it's you know, it is whatever. So let's talk about infinite series. So this is an infinite series. I'm sorry. Infinite series. So the sequence, remember, let's compare the sequence. The sequence is A1, comma, A2, comma, A3, and dot, 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 right? Ethan, I need you to put a phone away. I'm gonna get a fishing rod. Hang your phone right in between the buildings. Okay, so now this is a sequence. Now we have talked about, let's review a bit. We have talked about, we want to find out the sequence, go to convergent, diverge. What do? Limit x and approach to what? Infinity, right? And also we have absolute value theorem. If you have a -1, so we have done like says limits and approach infinity of a to the n. If they go to 0, then it's converge, right? Or you go to 1, it's converge, right? So sorry, go to numbers. Go to L. That's converge, right? So what if and also we have as a limit and approach infinity of absolute value a to the n is converge, then limit and approach infinity of a to the n converge. Sorry, a to the n converge. So those are review things. Review that we have done that. We also have two ways to compare of monotonic. Two ways to compare. Monotonic. What's monotonic? It's increasing, strictly increasing, or strictly decreasing, right? So strictly increasing or strictly decreasing. So the first way is take a derivative. The second way is what? Compare a to the n plus 1 and a to the n. And we did two questions to compare those. One is one stack, one on top of the other one. One is just simply just line up, distribute it, you'll find out. Like the true statement. If it's true statement, it's true. So those are all the things that we have reviewed. Now, compare the a to the n plus 1 and a to the n. Now, we're going to talk about infinite series. What's the difference between series and sequence? Well, again, series is adding every single term up. So infinite series is going to be n equal to 1. So this is called a sigma notation. And on the top is infinity. And this is equal to a to the n. Oh, sorry, not equal to a to the n. It's a to the n is equal to a1 plus a2 plus a3 dot 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 until a to the n. So this is called infinite series. So if I have S of 1, this is sum of the one term. That means A1. Is that okay? S of 2, that means A1 plus A2. And same thing as S3 is going to be A1 plus A2 plus A3. And that, so you might have it get S of n. S of n is going to be a1 plus a2 plus a3 dot 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 a to the n. So determine. So this is something that we need to make sure we understand. Definition of a converged and diverse series. Okay? So we have a summation of infinity of n equal to 1 of n to the 1. N to the n. This is also known as the n term partial sum. And which is above like that, Sn equal to a1 plus a2 plus a3 dot 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 to the a to the n. Is this okay so far? So we kind of repeated what we said, we write down. They say if the sequence of partial sum and we're going to denote as this s to the n converge to s, then the series of summation of n equal to 1 of infinity a to n converge.
Could you please break that sentence down?
Okay.
Just quickly.
Okay, so I don't make sure you can write this. So if the sequence of the partial sum s to the n, okay, is converged to a s, and we're gonna define the s in a second. Okay, then the series of summation n equal to 1 of infinity a to the n, that means you add up every single term, it's converged as well. Now, what is the sum of the series? So the s is equal to the sum of the series. So the s is also denotes a1 plus a2 plus a3, and then it's gonna keep on an, and even after that, just infinite long. It doesn't stop. Now, if you have 1 plus 2 plus 3 plus 4, that's diverge, right? If you keep on adding, just adding, the number just getting larger. But if you got 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32, that might be different. Okay. Now sometimes, if s to the n, this part diverge, then the series diverge. So in order to like show you something, that we're gonna start by looking at certain things. So what we're gonna do is we're gonna look at this one, right? We're gonna look at summation of n equal to 1 of infinity of 1 over 2 to the n. So I'll write out. This is probably gonna be 1/2 plus 1/4 plus 1/8 plus 1/16. And this is gonna keep on going, it doesn't stop. But if I wanted to have a list of partial sums, so let's say S1, that's gonna be 1/2, right? S2 is what? 1/2 plus 1/4, right? And S3 is equal to what? 1/2 plus 1/4 plus 1/8. And just keep on going. Now, what's my result here? My result is 1/2, and my result is here is what? 3/4. And my result here is what? 7/8. What is S to the n? What will be, well, let's do one more. Let's do one more. S to the 4 equal to 1/2 plus 1/4 plus 1/8 plus 1/16. So what's the result of this one? What's the result of this one? 15/16. Ian, you're not paying attention to me. Whatever's on your iPad, what are you reading? I know it's not math. And this is why you, when it's done, when you go home, you have absolutely no idea what's going on because you don't pay attention to me. And you don't write down stuff so you won't know what happened. What are you reading?
Nothing right now.
Okay. Can you come up a formula represent the Sn? What will be the formula I represent Sn? What'd you say, Gabby? No. It won't be n/n plus 1 because this is 4 and this is not 4. Hold on, Ian. Can you come up with an equation to represent this? Yes?
2 to the n minus 1 over 2n.
Yay. Nice. 2 to the n minus 1 over 2 to the n. Ian, is that what you're going to say?
Yeah.
Good job. I just need a different person to say it too.
See, can you try again what the relationship of this like S of n and A of n is?
A of n is sequence, S of n is sum of a sequence. So, and it's called series. Sum of sequence is known as series. Is this okay? What happened when limit approach infinity on this one? What happened? Yes, Lucia.
A equals 1.
Why do A equals 1?
Split 2 to the n. It becomes 1 minus 1 over 2 to the n. And that becomes 1 over infinity, which is 0. So it's just
So this part is, if you split up two different one, this one's going to go to 0 because bottom gets larger.
Yeah. If anybody was describing it.
So that's 1, right? Okay, this one's interesting. So for those of you guys don't know, this is also known as I'll ask you in a second. So, what do you guys think about this one? What do you think about this one? So we have 1 over n minus 1 over n plus 1 is what?
That's pretty cute.
It is cute.
What are you saying that I'm not
You asked me what I thought about it.
I mean, I didn't have to.
It is cute. Once you find the answer, you find out even cuter.
Wait, that was like flirty.
Huh?
That was like flirty up the phone.
Is it?
That was like once you find my answer. Okay.
You can flirt with math. It's okay.
This is one word.
He's like, are we good?
What are you saying? This is really cute. Falling down.
Yeah, we got it. We got it. What is
Hold on again.
I mean, that makes sense with that.
Separate. Shut up. Get to work.
Isn't that true?
What?
It keeps getting closer to 0.
Oh. We don't care about a sequence. We care about series.
Don't care.
Ah, Krishan's not here. So quiet. Sometimes Krishan's voice is kind of vibrant.
Yes, you can say that.
Yeah,
So this one is known as telescope sequence series. It has cube name too. So you will find out that if you write out the first few terms, so let's just say n equal to 1, it's going to be 1 minus 1 over 2, right? Plus what? 1 over 2 minus 1 over 3. Plus 1 over 3 minus 1 over 4, right? And if you keep on going, what do you see?
When the number deleted is 0, because you reach infinity, the number before it would move forward and so on, leaving only 1.
It's like
Yeah,
poop, 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 poop.
Why would it call it? Oh, it looks like it's zooming in.
I like it.
Now, if you zoom in, like I say, it's cute. The answer is 1. Because all the middle term will start canceling out.
Don't yuck my yum.
What'd you say?
Jesus is yucking my yum.
What does that mean?
I have a yum and Jesus is yucking it. You don't understand.
Yarn? I had a yarn.
I don't yuck my yum. It's like, oh, let's say I think peanut butter is really yummy, but Katie thinks peanut butter is yum. And then Katie's like, Lucia, I hate that you hate peanut butter. Katie's yucking my yum. What?
Y'all are too smart for me.
Hold on, still a guy from the dog.
Mr. Yang, it's a question.
Yeah.
What is the formula for S of n?
What is what?
The formula for S of n.
Well, yes, it's n over.
S of n. In this case, if we don't, S of n is going to be 1 minus 1 over n plus 1.
1 minus 1 over 1 minus.
1 minus 1 over n plus 1. Do you see that all the middle term cancel out? But remember, n is going to approach infinity, right? So if you limit this, n approach infinity, 1 minus 1 over n plus 1, what is it going to be?
So you would say like, oh, the answer to this series is 1, right?
The infinite series is
Okay.
converging into
But
1.
the one before it, the answer isn't 1. The limit is 1. What's the answer?
It's also converging into 1. Because if you limit approach infinity, the series, the sum of the series is going to go into 1. Just like you're eating half a pizza, 1/4 of pizza, 1/8 of pizza, 1/16 of pizza, you keep on eating it.
But if you add like, if you, oh, no, I got you.
Okay, now he's got 8.
Don't worry. Yeah, that's what we
Yes.
Why is there 1 minus? Like, if you have n plus 1 and plug in 1, you get.
Remember all the middle term, right? What happened?
Over n.
This is the only thing left, which is minus 1 over, this is the fourth term, right? The fourth term is 1 over 4 plus 1. But the problem is we're going to add to infinite long. All the middle term will cancel out, except the 1 over n plus 1.
And the final digit doesn't matter because at that point it is directly 1 over infinity, which is 0, so you're deleting a 0.
Exactly.
You add it up to cancel the 1 4 and plus 3.
What?
Which
I get a series of 1 over
I need to answer Lena's question. What's Lena's question?
Okay, so I get 1 minus 1 over n plus 1. I get 1 over.
it's 1 minus what's left among the series.
Oh, I think I
Can you help her? I don't understand what she's saying.
Well, like, look,
And so, what, and the n of the
you know, it's going
bottom,
to be left in the series.
What?
0.
and under the sigma, does that mean
But
how
that
many,
plus-
how
that
many
plus
numbers it
1 over
keeps
n
going
plus
up, or from what number it
But if I
starts?
didn't include the actual system,
From what number it start?
What number it starts?
Yeah.
You're not.
So if you plug in 1 first, and you're plugging the next integer, you do not plug in the number in between.
Would that be negative?
No, no. Usually start n equal to 1 or n equal to 0. Or it can be n equal to 2. I mean, usually you don't do negative.
But it can't be negative, right? Even if-
I mean, you can with the algebra 2 stuff, not with the sequence. Yes.
the series problem works and the sequence.
What?
you can start at 1 and 3.
You can start at 1, you can start at 0. But depends on the situation. We will tell you the slightly different, but not right now.
Starts at 1. If it started at 0, it would be 0 minus 1.
Well, do you do an n equals 2, you jump 2, 4, 6, 8, or do you?
No, you're gonna plug in 2. The first number you plug in is 2.
Oh, and then you keep going by 1.
Yeah.
Yeah.
2, 3, 4, 5.
Starting at 0 because then the answer would be infinity.
All right. So shh. I want you to try it, but you need to implement your own skill. Okay? I want you to try this series, but you need to implement your own old skill. And you want to think about which old skill that you want to be involved with. Not use substitution, no.
Just looking at it.
Just looking at it. Eli's method. Huh? Which old skill that you need? No.
Yeah, the conjugated thing.
I hear something like a close to getting a right answer there. Yeah. What did you learn recently that will help you break up this fraction? What? What did you learn recently? You can take one fraction and then break up the two fractions.
What are you using? Like why am I?
When you plug it in, or you just do the numerator.
First one it's gonna do sometimes people need to hear the truth. He's using a good degree, so shit.
You finish or no?
I finished the A part. I finished the partial fractions part.
Yeah. We're trying to find what happened equal to infinity.
Oh, second. Wait, but that's not.
No idea. Well, actually, I have like
I can do the same. Are you Eli?
Anybody got an answer?
I'm not sure.
Eli's like, I just look at it.
Well, no, because this is what this is. You didn't plug it in.
Oh, Peter's getting it.
Holy moly.
So you have to go do this.
It's not possible.
Okay, Peter, what did you discover?
Oh, it's the same thing as the last one.
Almost the same thing. It's also telescoping.
No.
Yeah, I know I'm very good.
Okay, so how many of you guys did partial fraction and end up to be 1 over 2m minus 1? minus over 2n plus 1. So that's why partial fraction is a very important skill to know. Like when you see bottom is factorable, not only you can use some integral, you can use some sequence, series as well. Okay, then we just start write shit down. So what happened is 1. We're gonna write a first few term. What happened is 1. 1, right? Minus what? 1 over 3rd, right? Plus, what happened if you plug in 2?
1 over 3 minus
1 over 3 minus what?
1 over 5.
1 over 5. Plus 1 over 5 minus what? 1 over 7 plus 1 over 7 minus 1 over 9 dot 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 dot. Now if you see the mixture of here, if you see the mixture here and also here and also here, you're eventually gonna go to 0. Well, what is the formula here? Because all the middle cancel out, would it be just S of n? S of n is represented by 1 minus 1 over 2n plus 1. Does that make sense? When I go to infinite, so I'm going to rewrite the questions. The question n equal to 1 summation 2 over 4n squared minus 1 equal to limits as n approach infinity of Sn, right? Equal to limits as n approach infinity of 1 minus 1 over 2n plus 1, because this is summarize everything. This is the summary of this, right? Eventually sum up all the sum. This will be all the middle term will cancel out, and this becomes 1.
Equation for Sn. Do you do the Eli method and just look at it?
There is no Eli method.
You just like look at it and you're like, oh, okay.
No. Just plug in the first few term and hopefully you see something, should see some pattern. Because you see a pattern, then you can write out your series, the partial sum pattern, if you come up with the correct one. If it's go to infinity, all the middle terms will go away, right? Why is a minus? Alejandro says why is minus a? See that minus right there. So a telescoping is actually pretty interesting. Okay, let's talk about another simple series. Is this converge or diverge?
You can't say it that way.
Why is diverge?
There's no n.
Yeah, it's just gonna be 1 plus 1 plus 1 plus 1 plus 1, right? And yeah, that's gonna go to infinite. So there's nothing I can do, just adding all the term. Okay. Let's talk about one question. Well, 100% on AP exam. 100%. I can bet my money on it every single test. It's always. I'll bet like $1,000.
Oh. Like the exact numbers, Mr.
No, not exact number.
Well, you didn't say how many made the bets, so. I thought it was a copy paste this day.
All right. This one is called geometric series. So how many series we learn right now?
Too many.
Telescope. Right? We learned telescope. We know the name, telescope. So we're gonna learn about geometric. Geometric series. So what is geometric series? It has a certain condition. Is n equal to 0, infinity of a r to the n. And that's equal to a over 1 minus r. And absolute value r has to be less than 1. So absolute value r has to be less than 1. What does that mean? That means, this means the r can be between -1 all the way to 1. So the common ratio is less than 1 is how do you make a previous term smaller? Does that make sense? For example, your common ratio is 1/2. Then 1 times 1/2 becomes half. And then times 1/2 is becomes 1/4. It times 1/4, and keep on 1/2, keep on going to 1/8 and 1/16. But the common ratio has to be between -1 and +1. Why? Because if greater than 1, what happened? You adding up the bigger number each time, then the series won't diverge. Does that make sense or no? Yes.
What does the equation say? It says equal to, right? Equal to one a over 1 minus r. What's
Yeah.
the rest?
The value r less than 1.
And then
Yeah, this is the condition. This is a condition.
A times
Absolute value. Absolute value.
Yeah.
And that's the condition.
That's a condition.
And then
Okay, what happens to the n?
the n, it says r to the n power.
Oh, where the n equal a over. Wait, so n started.
Mr. Ye, Separate has a question.
Well, who has a question?
Separate.
Say, what happens to the n? Like if it's a over 1 minus r. How does that change the?
A over 1 minus r. What happened?
Yeah, if that equals to that, what difference does that make it from like the same as the 1 plus series of 1 you put there? There's no n in there.
Yeah, there's no n in there.
Isn't it just like what kind of difference does that make from the 1 at the top of it?
So sometimes you can start at, okay, so let me write it down here. So this part, let me write that. Summation of n equal to 0 of summation of a to the r to the n is a, right? A is that the value that's always there, okay? Plus a to the r plus a to the r2 square. So a is like you know how like I have 2 bacteria and grows double each time, so it'll be 2 to the 2 to the n.
So it's a times r to the n.
Yeah, so you might think that's a sequence,
Yeah.
but it's not.
That's
A is like initial
I
value.
should have made it like b.
Yeah, so that's a good question. Plus a to the r to the n dot 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 dot. Also, a cannot equal to 0, by the way. It has to be like, if a equal to 0 and everything goes to 0, then that's no fun. You know how like you have a population growth of like 2 million people or like 10 million people, and that's your starting value. So that's your starting value, is to say.
Not enough. What do you mean? And so that's your question.
Okay. Any question about this part? So try with the pizza situation, right? So we know the pizza situation. We start with the 1 pizza, right? And so let's say this is a 1. This is the sequence is a 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16, right? And dot 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 dot. We know the result. We know the result, right? We know the result is. But we're gonna use this equation to find the result. Actually, you learned this in algebra 2. It's called infinite geometric series. So I'm gonna plug in 1, right? Equal to 1 minus half, right? So that's equal to 1 over 1/2, right? So that's 2. So if you start with the first day, you eat 1 pizza, and next day you have a pizza, you eat 1/4 pizza, you eat half less each time, that eventually is going to give you 2.
But I thought it was equal to 1, not 2. So where is the ratio?
Huh?
Is the ratio half?
Yeah, the ratios have A is 1. Uh-huh.
What if the end doesn't equal 0?
What it means, what?
Like at the what if we don't start on 0?
Not.
Well, here we only consider start as 0. Right now we consider as 0. There's some shift later. We're gonna happen later.
Why is 8 1 again?
What?
Why is 8
Oh,
1?
no.
The starting value is 1.
Starting value. A is right here.
And each time you multiply by half, right? So according to this ratio, 1/2, 1/4, 1/8, 1/16.
What did you say?
Is that okay?
Remove the original equation. 8 plus 8 r plus 8 r squared.
Is this okay? All right, we're gonna actually try one.
I got this one, bro.
All right, summation of n equal to 0, and this is infinity, and you got 3/2 to the n. Okay, so you want to find out what happened when they reach infinity? What would it be?
That's so simple.
So somehow you gotta rewrite it to like this, so that way you can see it.
Maybe it's the negative. So but where's
Huh?
maybe 8 to the negative 10. 8 times 4 is the negative. Is that a 2? I guess not. What do you mean? Is it 3/2?
You know, you play it a lot harder consistently on. It just keeps thinking back and forth.
Lisa does not have anything.
Yeah, so I need to charge my phone.
Isn't it all based on you can do this? Yes. Mark, you just Mark.
What'd you guys get? Let me guess, Katie. TikTok.
No.
Damn it. What is on today?
I was messaging my roommate.
Your roommate.
How do you have roommate?
The answer 6.
For college. Not yet.
Who are you gonna be rooming with?
You lied to the
Is
chick.
this the girl that we like? Yeah. Tolan?
Hey, Katie. What's the answer?
What's the answer?
6.
Well, how do you get 6?
Well, you just look at a number.
You just look at it.
Yeah, look at it. It just multiply by half. Just look at it. And that's the ratio. And start with 3. There's no way it can be this simple.
You cannot be just look at it.
Look. 3 over 2. 3 or 4. Yes.
On my exam, I'm ready to like
Okay, so
Eli's law requires public schools to install audio recording devices in locker rooms.
1 minute.
alright. Well, it's 6. Do you want me to go over it? Okay, so so why is 6? So this one you can rewrite as this one, right? Summation n equal to 0, infinity, and this is 3, right? Times 1 over 2 to the n, right? So this is the a, right? This is the r. This is just exponent rule. Understand how exponent works? Because that's also 1 to the n. 1 to the n doesn't imply anything. So it'll be 3 over...
I would really curve 1. That
Do you happen to have a TI-84 charger?
Why would I have?
I don't know, your math teacher?
I use Desmos.
Where's Bo? I need a fork. Anyone has a fork. I only know you don't know.
Okay, you know when you were like the really cold and then they were like, oh, we don't do that. I get a knock on my door. My dad's like, dude, I'm not opening the door. It's like 20 degrees out. And he looks at the rain. There's a little girl. She opens the door. She's like, do you want to come down cookie? And I was like, oh my god, like nothing in it.
Wow.
She's out cold though.
1 degree.
Because we can't encourage the mother. If the mother got all the money, she'd be like, oh, this is good. I'm gonna send her out of the cold again. But we can't. The poor girl probably had like hypothermia. It was terrible.
Oh, man.
No, you have to teach a lesson to the mother. What is this? I did this. But this one's down, I want to stick with the ball.
He got more questions.
But I didn't.
I did. I was like, you're technically keeping me in right here.
Maybe never here with this.
But they were like too hard at first, and then I learned them. And they were really hard on them. But
What do you
it'll be like that works because the rate inflation is so low.
He did not. He did not.
Did you mark down? Did you at least?
Like,
I'm not totally using my phone. Yeah. Work.
Like the tension and like motivation.
you think good? You think I can make this?
I'll remember that. I need an angle, but I think I'm an angle. You didn't study or did you play?
Excuse me. First of all,
I would look to good. Just to make sure.
You'll have to do the.
I'll try to get it.
Look, I see when you're okay. I'll sit somewhere else. It's gonna be easier sitting in your class.
There is no left.
Wait, is that here?
Yeah, it's not here.
I know what happened. Stop talking right now. You're just depressing.
Test last.
Wait, when
What was the average?
It's only like nobody can do.
That's so
So probably don't show because it's on the truck. I don't know what you get.
Dude, I said I don't remember it. It was just the worst sex. It was the worst sex. Now, do you remember?
I had a chess. Oh, my birthday.
Not Mr. Yam, up $2.37.
I lost $100 was okay. It's not that bad. Actually, lost $200 is okay. It's not bad. I made $1. Nvidia's up. Finally.
Yeah.
Nvidia's up.
Oh, it's up to today.
No.
Remember how the average was for the applications last year?
Not a clue. The only test I ever failed was kinematics, so I know I didn't fail it.
Oh.
You didn't fail rotation?
You should have failed. You should have lost. You should
Why did we break down about this? I feel like the sub in this unit hasn't been insanely hard.
No?
I just like how you put this in. I bet it's like, I know, like this is like this is easier than like
I'll take it like a man, bro.
Coming back.
Yeah, I know.
my question is, you guys help me out even though I've been writing this on.
I don't know, like nobody is not the course. But if I'm going after it, it's literally just. Because the reason why they did that, and I didn't want to do bad. So
This is that.
yeah.
Okay.
Or if it's intelligence rate. Oh, song, we just saw beauty of
And it's the integer, so every time you want.
Oh wait, 8, 5, and 9. Well, I could do. You didn't do that. Oh, you did.
part, and you got the
That can be fun when they're ready
You know what
that's great.
But we did that already.
Yeah, I mean, I didn't get it right though.
Yeah, we have. So that was a great version.
Wait, number 10.
What the hell is this though?
Bro, I gotta find one there. I was stood up and started clapping for Arthur. That's like the only time I'm proud of Arthur being able to
What did the exact word Arthur say?
Top 10 most despicable
Which
moments for
one?
Arthur.
I don't know.
He was like, I bet you could ask every single person in this room, and not one will say that we've done anything in this class all year. Like, that was pretty much word for word.
He said something about cheating too.
Oh yeah, he said, I can't cheat optimally if I'm sitting here. He said that twice. He kept saying it. What's that song?
Don't tell it. Yeah. You know about it?
What do you know?
The other thing he's proud of and he's a little bit for physics one of the days everything else for I'm considering getting one of the machines and piss them off. Yeah, I'm like, you can give them the empty test. I like, yeah, don't even give them the yeah, like that, bro. This is what we call it. Bro, everybody should leave the classroom with it. Why is it like, like, as an act of focus, go to stand up and leave the class.
But he hasn't taken the mock. I don't know if he wants to go to the
I am on the ball. We're all laughing around, bro. What is the oh my god.
They do but read my heart. It's like derivative.
No, bro. He's like doing this, and then all his stomach comes out, and then, bro, I forgot that his name, but oh, I can't.
Yeah, there's gonna be high in there. So all
Yeah, like we was doing this, I walked by us, he just didn't know and just started flashing that one was not in serious mark. Nobody took that mark serious.
Yeah, no one's for So I go over you.
I think he was on the extent. Okay.
I have no idea what this is.
That's why I have a pizza today. Great.
Whoever did it.
Okay.
You know how to do this?
We have everything. I learned everything this year, actually. As you can see, now for 3 years, my third year doing it.
Like, I'm not doing it like outside.
So period is 5. Yeah. I'm good. Yeah.
No one else knows. But I feel like I'm not my toes. Curled up, like,
Yo, do you know how to find equations for cosine and sine when looking at a graph like this? Like, you know how to think of equations that rotate the graph? So we are given a graph and we have to find the equation. So you look at this graph, and you're like, okay, there's no equation with the graph.
we might have the answer.
Where are they at?
You know what? You seem to be very hesitant.
No, you were there.
It's not even about, I can't just like hear it and then know it immediately. I gotta do it over and over.
Literally
A few days, you're not wrong.
the W times sigma f times r squared, sigma inertia cancels up, and sigma that's on the paper, right? Actually.
Oh yeah, I wrote this down.
That's really important.
Yeah, I was gonna go watch your stream, but I just don't know how to find a period for something like that.
Period is always my king of people. Negative pi over 9 to 7 pi over 9. What's the difference?
Complained about my silverware not being cleaned enough. And then Max locked all the doors at my house. Like, he's running around all the doors.
I'll see how good we do. Do it.
I think you're still alive, Mr. Yet.
This was only live for 2 hours.